For problem 3, we have 3 different limits to look at. Now these are limits that we can attack algebraically. You can also do them now using L'Hopital's rule, but I'm just going to do them algebraically. So the first one is the limit as x approaches 1 of x squared minus 2x plus 1 over x squared minus 1. And you can verify that if you plug 1 into the top and the bottom, you get 0 over 0. So A, you can apply L'Hopital, but B, you can factor the top and the bottom because they're both polynomials with 1 as a root. So the top factors into x minus 1 squared, x minus 1 times x minus 1. And the bottom factors is the difference of squares, x minus 1 times x plus 1. And so that means that a factor of x minus 1 downstairs cancels with one of the factors of x minus 1 upstairs. And that leaves us with x minus 1 over x plus 1. Now I try to stick in 1 again. I get 1 minus 1 over 1 plus 1. That's 1 over 2, which is equal to 0. Great. If you did L'Hopital, you can check that. That still gives you 0. All right, the second one, it looks like one of those derivative limits. I'm not putting any derivative limits, I'm not putting any definition of derivative via limits problems on the test, of course. But this sort of thing, even though it looks like it, it doesn't refer to derivatives, so I don't feel bad about giving this to you. Anyways, if you try to plug in 0 into this limit as h goes to 0 of 1 plus h squared minus 1 over h, you get 0 over 0. So again, that means that we should be able to factor, but the bottom is just h, so that means we should be able to find a factor of h on top. Well, the top is 1 plus h squared minus 1. I don't see a factor of h. And the problem is that the 1 plus h squared needs to get squared out first. So we'll square that out. You can FOIL it if you like, but it's really faster to remember the squaring formula for a binomial. I get 1 plus 2h plus h squared minus 1 over h. This 1 and the minus 1 cancel out, leaving me with 2h plus h squared over h. I can divide both guys upstairs by this h, leaving me with 2 plus h. So I plug in 0 and I get 2 plus 0, so this is just 2. Finally, we're looking at the limit as x goes to 9 of the square root of x minus 3 over x minus 9. Now this guy, if you plug in 9, you get 0 over 0. The problem is the top is not a polynomial, so we can't really factor it. But when we see this sort of root expression, we know that we can multiply by the conjugate of the root on top and on bottom, and that should allow us to find a factor. It'll rationalize the top, turn it into a polynomial, and we should then be able to find an appropriate factor to cancel. So I'll let you work through the algebra, but the top simplifies to x minus 9. It's the square root of x squared minus 3 squared, which is x minus 9, over, people really like to multiply out these this polynomial against this root expression. There's no reason to do so. Look, this x minus 9 up top is going to cancel with this x minus 9 at the bottom. Don't multiply it out, just leave it there. So x minus 9, it looks like a cube, but that's supposed to be a 9, times the square root of x plus 3. The x minus sign upstairs cancels with x minus 9 downstairs, leaving just a 1 on top. I can plug in, I get 1 over the square root of 9 plus 3, which is 1 over 3 plus 3, which is 1 over 6. Fantastic. Come on.